morning and Jai Swaminarayan to all. Today for Standard 11th Science, in Physics subject we are going to continue our Chapter 3. The title of Chapter 3 was Motion in Straight Line. Up till now we have studied the introduction and position, path length and displacement. Today we are going to continue for further topics. The topics that we are going to cover today are average velocity and average speed, and another one is instantaneous velocity and instantaneous speed. So let's start with average velocity and average speed. So first we will look into average velocity. When an object is in motion, it changes its position with time. But how fast it changes its position and in what direction is the question. In order to describe this, we define a quantity which is called average velocity. The definition of average velocity is, it is defined as change in position or displacement divided by time interval in which displacement occurs. The formula for average velocity V is equals to x2 minus x1, which is our displacement, divided by t2 minus t1, which is our time interval, and hence average velocity V is equals to delta x, means displacement, divided by delta t, means time interval. Average velocity V is equals to displacement divided by time interval, where x2 and x1 are positions of the object at time t2 and t1 respectively. The SI unit of velocity is meter per second or meter second inverse. And also like displacement, average velocity is a vector quantity. Now consider the graph that is shown in figure 3.3, the portion of xt graph that is between 0 to 8 seconds is blown up in figure 3.4, means the area of figure 3.3 from 0 to 8 seconds is blown up and displayed in figure 3.4. As seen from the plot, the average velocity of car between time interval t is equals to 5 and t is equals to 7 is calculated here. According to the calculation, the value of our t1 is equals to 5 and value of t2 is equals to 7. And from figure 3.4 we can get the value of our x2 as 27.4 and x1 as 10. And by putting this value in our equation and solving it, we will get the answer 8.7 meter per second. The average velocity can either be positive or negative, and if displacement is 0, then the average velocity is also 0. Now figure 3.5 shows us the graph of all the 3 points that we discussed. The figure 3.5a is the graph for positive velocity, which is a uniform line going upward. The figure 3.5b is for negative velocity, where you can see that the line is coming downward, and figure 3.5c, which is for zero displacement, zero velocity, which is straight line. Average velocity as defined involves only displacement of the object. We have seen that earlier the magnitude of displacement may be different from actual path length, meaning that the displacement value and actual path length value cannot be same, they may be different. And to describe the rate of motion over the actual path, we introduce another quantity which is called average speed. Looking to the definition of average speed, average speed is defined as total path length divided by total time interval during which the motion has taken place. Here is the equation or formula for average speed, which is average speed is equals to total path length divided by total time interval, and that will be our equation 3.2. Also, the unit of average speed is same as average velocity, which is meter per second or meter second inverse, but the difference between average speed and average velocity is that average speed does not tell us that in which direction the object is moving, and thus the object is always assumed to be moved in forward direction and it is always positive. If motion of an object is a straight line or on a straight line and also in same direction, then the value of total path length and magnitude of the displacement will be same or equal. Now we will look at an example that how to calculate average velocity and average speed. According to the example, a car is moving along a straight line, say OP, means car is traveling from O origin to P. In figure given below you can see that it moves from O to P and it takes 18 seconds to move from O to P, and then the car returns from P to Q and take another 6 seconds. We have to calculate the average velocity and average speed for two cases. Case 1 is from O to P, which is A, and case 2 is from O to P and back to Q, which is B. So let us look at case A, which is to calculate the average velocity and average speed from O to P. As you know, the formula for average velocity is equals to displacement divided by time interval, and in this case the displacement value is P, which is our ending point. So if we calculate displacement, ending point minus initial point is 360 minus 0, which will give us 360. So our displacement will be 360 and time interval taken is already given in the question, which is 18 seconds. Now calculating these values, we will get the answer for average velocity v is equals to 20 meter per second. Now we will calculate average speed. The formula for average speed is equals to path length divided by time interval. Here path length is 360 meter as the car covered from 0 to P, which is 360 meters, and the time interval is same 18 seconds, which is already mentioned in the question. And also calculating this, we will get the same answer, which is 20 meter per second. So for this case, the value of average velocity and average speed is same, which is 20 meter per second. Now we will calculate the average velocity and average speed for case B, which was to calculate the distance from O to P and then coming back to Q. So for that case, the average velocity is equals to displacement divided by time interval. Now in this case, our car goes to 360 meter and comes back to 240 meter. So the ending point minus initial point will be 240 minus 0, which will give us 240 as our displacement. But the time interval will be different. Here the time interval is from O to P it is 18 seconds and then from P to Q it is 6 seconds another. So 18 plus 6 seconds will be 24, and by calculating this we will get the value of average velocity is equals to 10 meter per second. Now we will calculate average speed for this case, where the value of path length will be from O to P plus P to Q, and the time interval will be also same as average velocity, which is 24 seconds. So the value of path length will be 360 plus 120, and that will be divided by 24 seconds, and the answer that we get for our average speed is 20 meter per second. So in case B, our average velocity is equals to 10 meter per second and average speed is equals to 20 meter per second, and both are different in this case. Now we will start another topic, which is instantaneous velocity and speed. Starting with instantaneous velocity. So as we know that the average velocity tells us how fast an object has been moving over a given time interval. But it does not tell us that how fast the object is moving at different instants of time during that interval. Means if you want to know that in particular instant how much speed the object is moving, we have to use another quantity, which is instantaneous velocity or simply velocity at an instant t. Looking to the definition, the velocity at an instant is defined as the limit of average velocity as the time interval delta t becomes infinitesimally small. In other words, we can say by the equation that velocity v or instantaneous velocity v is equals to delta x divided by delta t, means displacement, divided by time interval with a limit of t tending to 0, which is our equation 3.3a. And by more generalizing this equation, we will get the value of velocity v is equals to dx divided by dt, differential coefficient of x with respect to time, which will be our equation 3.3p. Here in equation 3.3a, the symbol limit t tending to 0 stands for the operation of taking limit as of t tending to 0 the quantity on its right. In the language of calculus, the quantity on the right hand side of the equation 3.3a, which was delta x divided by delta t with limit tending t to 0, is also said to be differential coefficient of x with respect to t, and it is denoted by dx divided by dt. It is the rate of change of position with respect to time at that particular instant. So we can say that the value of velocity v is equals to dx by dt is our equation or formula to calculate instantaneous velocity. We can also use the equation 3.3a for obtaining the value of velocity at a particular instant, either graphically or calculating numerically. Suppose that we want to obtain graphically the value of velocity at time t is equals to 4 seconds. For the motion of a car that is represented in figure 3.3, which you have already seen previously, the figure has been redrawn in figure 3.6, choosing different scales to facilitate the calculation. Now, let us take the value of delta t is equals to 2 seconds, which is centered at time instant 4 seconds. Then, by the definition of average velocity, the slope of the line P1 and P2 that is shown in figure 3.6 gives the value of average velocity over the time interval 3 seconds to 5 seconds. Means, when we take the value of delta t is equals to 2 seconds at a particular time instant of 4 seconds, then according to average velocity, the slope of line P1, P2 will give us the average velocity in time interval 3 seconds to 5 seconds. But what if we decrease the value of delta t from 2 seconds to 1 second? If we do so, then the line P1 and P2 will become Q1 and Q2, and it will give the slope and the value of average velocity over the time interval of 3.5 to 4.5 rather than 3 to 5 seconds. Means, in case of delta t is equals to 2 seconds, we get average velocity over interval 3 seconds to 5 seconds. But in the case of value of delta t is equals to 1 second, we will get our average velocity over the interval of 3.5 seconds to 4.5 seconds. In the limit of t tending to 0, the line P1 and P2 will become the tangent to the position time of the curve at a point P. The point P in figure is displayed between T1 and T2 points. You can see that. And the velocity at time instant t equals to 4 is given by the slope of tangent at that particular point. But it is difficult to show this process graphically and also to understand this process graphically. But if we use numerical method to obtain the value of velocity, the meaning and limiting process become clear. So by using a numerical method, we can understand this thing clearly. As you can see in table 3.1, we have taken the numerical method. For the graph that is shown in figure 3.6, the value of x is equals to 0.08 t. And in table 3.1, it gives us the value of delta x divided by delta t displacement by divided by time interval, which is calculated for different values of t, which are 2 seconds, 1 second, 0.5 second, 0.1 second and 0.01 second. Means in each case we are decreasing the value of t, and the time instant that we are using is 4 seconds. This was the value of time interval delta t was our first column, which is 2 second, 1 second, 0.5 second, 0.1 second and 0.01 second. Now we will get the value of our second and third column. For that we have a formula. For second column, which is to calculate t1, we have a formula that t1 is equals to t minus delta t divided by 2. So to calculate t1, we will require the value of t, which is 4 seconds, and the value of delta t for first case, second case, third case, fourth case and fifth case we have. So for the first case, the value of delta t will be 2. For second case, it will be 1, and rest for
all the three cases. So for the first case, if we want to calculate the value of t1, we will have to substitute the value as t1 is equals to t minus delta t divided by 2, means t1 is equals to 4 minus 2 divided by 2, and by substituting that equation we will get our answer for the first case of t1, which is 3. And there is also the formula to calculate t2, which is our third column. Formula for t2 is equals to t plus delta t divided by 2. Here also we require t and value of delta t. So the value of t as we know is 4 and value of delta t for the first case is 2. When we substitute these values in the equation, we will get the value for t2 as 5. Similarly, we can calculate the value of t1 and t2 for the rest of the cases. Now coming to fourth and fifth column, which is to calculate x of t1 and x of t2. So to calculate x of t1, as we already know, the value of x is 0.08. We get this value from figure 3.6. So the value of x is 0.08, and for the fourth column, which is x multiplied t1, we will substitute the value of x as 0.08 multiplied by t1. So for the first case, we will take the value first of t1, which is 3. We will multiply 3 with 0.08 and we will get the answer. Similarly, for calculating the fifth column, which is x multiplied t2, we will substitute the value of x as 0.08 and the first value of t2 for first case, which is 5. By doing this, for all the other cases, you will get the answer for column number 4 and column number 5. For column number 4 is x multiplied t1 and column number 4 is x multiplied t2, and by calculating with this way, we will get all the values of column 4th and 5th. Up till now, we have seen that for table 3.1, we have calculated the value up to 5th column. Now we will move to 6th column. In order to calculate the value of 6th column, we have the equation for delta x, which is for a calculation for our 6th column. Delta x is equals to 5th column minus 4th column, means the value of 4th column is subtracted from the value of 5th column. So to get the value of 6th column, we have to do minus between 5th column and 4th column, and in this way we will get the value of our 6th column. And now coming to the last column, which is the ratio of delta x, which is displacement divided by delta t, which is the time interval. We have to take the ratio of these two columns. Another time I am saying that for the last column, we have to take the ratio of column number 6 and column number 1st, which is delta x divided by delta t, and we will get our answer for the last columns. Now we see from table 3.1 that when we decrease the value of delta t from 2.0 to 1 to 0.5, then 0.1 and 0.01, the value of average velocity approaches to the limiting value, which is 3.84 meter per second. And that is the value of average velocity at time instant 4, means that is the value of dx by dt at time instant t is equals to 4 seconds. Also, the graphical method for the determination of instantaneous velocity is not always a convenient method, as we discussed previously that in order to use graphical method, you have to be more careful to plot the positions in the time graph. If you do not do so, then your graph can become wrong. So the graphical method is not always convenient. You must carefully plot the position time graph and calculate the value of average velocity as the value of delta t time interval becomes smaller and smaller. Then we calculate our displacement divided by time interval delta x divided by delta t from the data for decreasing value of delta t time interval and find the limiting value as we have done in table 3.1, or we can use differential calculus for giving the expression and calculate dx by dt at different instant. We will do an example for instantaneous velocity. Now, according to the example, the position of an object moving along x-axis is given by x. The value of x is equals to a plus bt, where value of A is equals to 8.5 meter and value of B is equals to 2.5 meter per second, and t is measured in second. We have to calculate its velocity at time interval t equals to 0 and t equals to 2 seconds, and also we have to calculate average velocity between time interval 2 seconds to 4 seconds. So going ahead to our answer, in notation of differential calculus, the velocity is v is equals to dx by dt. Here we have our value of x is equals to a plus bt. So we will substitute that value in our equation, putting that value in place of x, which will give us the equation as below, and by solving it further we will get the value is equals to 2bt. Now we know that the value of b is 2.5. Multiplying 2.5 with 2 we will get answer 5, and the value of t is not known right now, so the value of v will be equals to 5 t meter per second. Now the velocity at time interval t is equals to 0 will be substituted in this value, means at the place of 5, in the place of t, in 5t we will substitute value 0 to calculate the velocity at time t is equals to 0. When we substitute t equals to 0, t multiply means 0 multiply 5 will be 0. So the velocity at t is equals to 0 will be 0. But for second time interval t, which is 2 seconds, we will substitute the value of t as 2. So 2 multiply 5 will be 10. So for t equals to 2 seconds, we will get the velocity as 10 meter per second. Now we will move to calculating the average velocity between 2 seconds to 4 seconds. Here 4 seconds and 2 seconds are our different values of t's in the equation. Average velocity is equals to x multiply 4.0 minus x multiply 2.0. Now here 4.0 is our t value for first x and 2.0 is our t value for second x, and also we have to substitute the value of x is equals to a plus bt, where the value of a is 8.5, value of b is 2.5, and value for t for first x will be 4 and value of t for second x will be 2. So by distributing this value and solving it further, we will get value as a plus 16b minus a minus 4b whole divided by 2, as 4 minus 2 will be 2 in denominator. Now solving this further, we will get the value 6 multiplied by b. Now we will substitute the value of b as 2.5 and we will get further 6 multiplied by 2.5, and when we will multiply 6 with 2.5 we will get the answer 15 meter per second. So our average velocity between time interval 2 second to 4 second will be, or 2 second and 4 second will be 15 meter per second. Let us summarize that the velocity at time interval t equals to 0 will be 0 and time interval t equals to 2 will be 10 meter per second, and the average velocity between time interval 2 seconds and 4 seconds will be 15 meter per second, as we have calculated here. We have seen about instantaneous velocity. Now we will come to instantaneous speed. Coming to the definition, instantaneous speed or simply speed is the magnitude of velocity. For example, if we take the value of velocity as plus 24 meter per second or minus 24 meter per second, it will not affect the speed. In both the cases, the value of speed will be 24 meter per second, which is positive 24. As we have also discussed earlier, then in case of speed, we does not know that either in which direction the object is moving. We always assume that the object is moving in forward direction and it will give us the answer in positive. So rather we take the value of velocity as plus 24 or we take the value of velocity as minus 24, it will not affect the value of speed. The value of speed will be 24 meter per second, or we can say plus positive 24 meter per second. There is a note for you that it should be noted that though average speed over a finite interval of time is greater or equal to magnitude of average velocity. This was the note. Now, instantaneous speed at an instant is equals to the magnitude of instantaneous velocity at that instant. Means according to definition, we have seen that the instantaneous speed is the magnitude of velocity, and on the basis of that the value of magnitude of instantaneous velocity and the value of instantaneous speed is equal. This was instantaneous speed. So up till now we have discussed about average velocity and average speed and instantaneous velocity and instantaneous speed. Further topic we will discuss afterwards. That is it for today. Thank you.